Let us also try to solve the next question, 28th question. Two bodies of masses 1 kg and 2 kg respectively are placed at a separation of 1 meter. So, two bodies are given, 1 kg as well as 2 kg, and distance of separation is 1 meter. Acceleration of the body is assuming that only gravitational force. So, it asks you to find out acceleration of each body. Acceleration of the first body as well as acceleration of the second body. First of all, let us try to find the force between the two bodies. So, what is the force between the two bodies? Formula for force between the two bodies, F is equals to G m1 m2 by r square. The one and only one formula. So, where the value of G, generally we consider it as 6.67 into 10 power minus 11. Mass of first body 1 kg. Mass of second body 2 kg. That's it, nothing else. G 6.67 10 power minus 11. Mass of first body 1 kg. Mass of the second kg 1 kg. Separation of 1 meter. So, distance of separation is 1 meter. So, 1 square. Hence, the value of S is equals to 6.67 into 1 into 2 is 2 multiplied by 2 times of this is 10 power minus 11. 1 squared is 1. So, will not change anything. So, value is 6.67 into 2 times of 10 power 11 minus 11. So, how much is that, children? This is 7 to 14, 13. So, 13.34 multiplied by 10 power minus 11. So, what is that? 13.34. But here we have 1.33 something. So, let us remove, because here power 11 is 1.33. If you want to write it as 1.33, this will be decimal. If you bring here, it will become 1.334 into 10 power minus 10. So, one decimal I removed. So, that minus 11 will become minus 10. So, what is the force between the two bodies? The force between the two bodies is 1.334, or simply I can 2 decimals, up to 2 decimals, F is equals to 1.33 into 10 power minus 10 Newton. But are they asking us to find out the force or acceleration? They are not asking us to find out the force. They are asking us to find the accelerations. Find the acceleration of the bodies. So, nowhere you are asked to find out force. So, what is the formula to find out acceleration, children? As we know that F is equals to ma. So, acceleration A must be equals to F by m. So, how to find out acceleration? By applying the formula A is equals to F by m. So, have to find out the acceleration of the first body as well as the acceleration of the second body. So, what is the value of acceleration of the first body? A1 is equals to, between the two bodies, same force is acting. So, A1 will be F by mass of the first body, and A2 will be force between the two bodies and mass of the second body. So, what is the formula for A1? F by m1. What is the force given? 1.33 into 10 power minus 10 newtons upon. How much is the mass of the first body? It is 1 kg. So, upon 1, you will get it as 1.33 into 10 power minus 10 meter per second square. So, what is the acceleration of the first body? 1.33 into 10 power minus 10 meter per second square. Similarly, acceleration of the second body is F by m2. How much is the force between the two bodies? 1.33 into 10 power minus 10 upon mass of the second body. What is the mass of the second body? They gave it as 2 kg. So, by 2. Simplification, you will be getting this as 6 to 12. Again 6 to 12. So, something like 0.666 something, we are getting it as into 10 power minus 10 meter per second square. Or decimal, because it was given as 6 point. Once you bring the decimal to the other side, it will become 6.666 so on into 10 power minus 11 meter per second square. This decimal I carried to the right side, so minus 10 became minus 11, or this can also be written as approximately 6.67 into 10 power minus 11 meter per second square. So which one is the correct option, children? First one you are getting it as 1.33 into 10 power minus 10, and the second one you are getting it as 6.67 into 10 power minus 11 meter per second square. Hence, the correct option must be option A. Okay. Well, moving ahead with the next question, 29th question, children. Communication satellites move in the orbits of radius 44,400 kilometers around the Earth. So, Earth is there. So, we know that around the Earth, satellites will be moving around the Earth. Okay. Moon is a natural satellite, as well as there are few artificial satellites also called as communication satellites, and they revolve around the Earth in some orbit. So, they gave that the communication satellites move in these orbits of radius 44,400 kilometers. How much is that? 44,400 kilometers, because it's a lengthy value. Radius of the Earth is 6,400 kilometers, and this 44,400 kilometers is very large. So, we have to consider this orbit value as from the center of the Earth you have to consider. If the value of h is very less when compared to the radius of the Earth, then we can consider it as r plus h, but it is very large, so directly you can consider it from center of the Earth. So, r is 6,400 kilometers, r plus h itself is 44,400 kilometers. This must be clear, children. So, what is that? Earth. This is your communication satellite. This distance is 44,400 kilometers. So, radius of the Earth, as we know it as 6,400 kilometers, and from here to here, radius of the Earth along with the height, this is r and this is h. R plus h is found to be 44,400 kilometers. These are the values. The acceleration of such a satellite, assuming the only force acting is, so you're asked to find out the acceleration. Children, as we know that G, relation between G, okay, with respect to H, so G is equals to G times of R by R plus H whole square. What is the value? G is equals to G times of R by R plus H whole square. So, how you got this relation? Let me explain this also carefully. We know the value of G as G m by R square. Here m is the mass of the communication satellite. Okay. Similarly, this is on the surface of the Earth. At a height h, we take it as GH is equals to same universal gravitation, it is constant, and mass is same communicational satellite m upon, now distance is r plus h whole square. Equation 1 and equation 2. If you divide equation 2 with equation 1, we'll be getting it as Gm by R plus H whole square upon Gm by R square. Proper simplification gives Gm gets cancelled. This will be R by R plus H, R square by R plus H whole square. And this can also be written as R by R plus H whole square. So, what is the value of equation 2 by equation 1? You are getting it as GH by G is equals to R by R plus H whole square. So, carrying the same formula, let us check what happens. So, what is our formula? GH by G is found to be R by R plus H whole square. What was the value of R? 6,400 kilometers. What was the R plus H? 44,400 kilometers. So, let us substitute those values. So, GH by G is found to be 6,400 kilometers upon 44,400 kilometers whole square. 0, 0 gets cancelled. Okay. So, you are left with this with 4, 6 4s 24, 16 upon 111 whole square. Okay. Hence, the value of GH upon G is equals to 16 times 16, 16 square by 111 multiplied by 111. That's it, children. So, what is the proper value? This GH upon G is found to be 256 multiplied by 12321. So, how much is the value you are getting it as? 256 upon 12321. Or the value of G is, G you bring it here, G times of 256 upon 12321, and we know the value of G as 9.8 meter per second square on the surface of the earth multiplied by 256 times of 12321. So this further simplification may give you as, you need to divide this carefully, children. So how much is that? The value of GH is found to be 2498.8 upon 12321. Okay, so this can be written as, if I take this decimal out, then it will be something like 0.12. This is 24. It's almost double to that. So I can approximately take it as 0.2 meter per second square. I hope the simplification is clear, children. So what I did is, G value I considered it as 9.8. This is 256 and this is 12321 as it is. I multiply 9.8 with 256 to get 249.8 upon 12321. So what I did is, I took this decimal in. So this will become 24988 into 10 power. I'll just show it to you. So GH will be equals to, so after multiplying to 9.8 with 256, I got it as 2498.8. May I write this as 24988 into 10 power minus 1 whole upon 12321. Yes. So double of 12321 is approximately 24988. Approximately. So what is the value? 12321 multiplied by 2. You will be getting it as something like 2464. This is 2498. It's approximately double to that. So this will be GH is equals to 2 multiplied by 10 power minus 1, or GH is approximately taken as 0.2 meter per second square, and hence the correct option is option C. So simplification, be thorough of the simplification, children. So this, look at this carefully, and everything is a common value. You know the values of G. Okay, substituting the value of R and R plus H, and proper simplification will give you the correct result. Okay. Let us move to the next question, that is question number 30. Two persons weighing 50 kg and 60 kg. So what are the masses given? One is 50 kg, the other is 60 kg, seated across a table. So a table is there and these two persons are sitting across that. If they are 1 meter apart, the gravitational forces. So some table is there, one person is sitting here and the other person is sitting here. Well, and the distance of separation between the two bodies were given as how much? 1 meter apart. Mass of the first person is given as 50 kg, whereas the mass of the second person is given as 60 kg. So two masses are known, distance of separation is also known. You are asked to find out the gravitational force. What is the formula for gravitational force? G m1 m2 by r squared. Masses are known, distance of separation are also known. Simplify, you will be getting it. So F is equals to, value of G is 6.67 into 10 power minus 11 Mass of the first person is 50 kg and mass of the second person is 60 kg. Distance of the separation is 1. So 1 square. So F is equals to 6.67 into 50 times of 60. You'll be getting it as 30. This is 3000 multiplied by 10 power minus 11. 1 square is 1, so no need to write. Or F can be written as 6.67 times of 3000 can be written as 6.67 into 3. These 3 zeros, if it is added here, it will become 10 power minus 8. So this is the proper value of F. So multiply 6.67 with 3 children, 6.67 with the 3, if you multiply, you're getting as 20.07. Okay, so F is found to be 20.07 multiplied by 10 power minus 8. But here only single numbers are there, so I can take this decimal in. So this decimal moving towards the left side, it will become 2.007 times of 10 power. As I took the decimal in, I can now replace this minus 8 with minus 7. So F is approximately taken as 2 into 10 power minus 7 Newton. So what is the force acting between the two persons? It is 2 into 10 power minus 7 Newton, and hence option B must be true.